Okay, so what is this? Well, this is the chapters 1 and 2 review. When you have a new teacher, it's a little difficult to be able to determine how she's going to ask questions for a test. And so the majority of the test will be multiple choice. I haven't picked out any essays yet, but I would look at the beginning of the chapters where I have some questions written there. I will take it from that pool, okay? All right, so here's what you need to do. Why don't you take out a piece of paper or several, and I'm going to have you write down the answers. So sometimes it's easy to listen passively and think you've got it, but it's another thing when you've got to come up with the answer. So I want you to physically write down the letter of the answer. That means that you had to think about it. So it's in the brain and it's getting you ready for the test. Okay? All right, here we go. Okay. In environmental health, the environment and ecosystem are very similar, except that the environment is A, in balance, B, can be impacted by humans and placed out of balance, C, does not include non-living characteristics, D, does not include living organisms, E, does not include humans. So what is your answer? Okay, so the ecosystem is imbalanced, but your answer should be B. The environment can be impacted by humans and placed out of balance. All right? Okay, number 2. Environmental health core concerns focus on A, noise pollution, B, lead contamination, C, wars, D, cholera, E, genetics, F, all of the above. And by the way, feel free to pause to think of things before I give you an answer. Okay, yes, it should be all of the above. Okay, good. Moving on. Hazards produced by humans, should be hazards produced by humans, are known as, by definition, epigenetic, A, B, anthropogenic, C, pharmacokinetic, D, genetic. And of course, the answer is B, anthropogenic. Good. All right, moving on. We say that genetics loads the gun, but the environment pulls the trigger. What does this really refer to? A, epigenetics, B, anthropogenics, C, pharmacokinetics, or D, genetics? Of course, the answer should be A, epigenetics. So something beyond the genes. So when you have a trait that is expressed, something happens, a lot of times a health event, it's not just your genes, it's usually something to do with the environment as well. A lot of times the environment interacts with genes. That's epigenetics. Okay, good. What is not the role of an environmental health practitioner? Should be a question mark there. Okay. I did this rather quickly, so forgive my slides. Okay, so what is not the role of environmental health practitioner? A, promote policies to protect the community. B, communicate possible hazard risks to the community. C, prescribe treatments to the community. D, monitor pollution levels. E, protect public health. Of course, the answer is C, prescribe treatments to the community. That's not something that an environmental health practitioner does. So they need to see their physician for that one, right? Okay, moving on. A natural toxic substance, by definition, is called A, toxicant, B, toxin, C, carcinogen, D, body burden, E, bioaccumulation. I'm overpronouncing these things. Okay, count it down to 2. Did you say toxin, B? If you did, then you are correct. Moving on. Toxicants can be released and travel into the air, water, and soil by many natural and anthropogenic means. Okay. Sometimes they change or transform as they move. So this is all known as A, hazard and risk, B, dose and response, C, exposure and volatility, D, fate and transport, E, epigenetics. I know you're thinking, oh, we saw epigenetics before, that can't be it. D, fate and transport. Good job. All right, moving on. Ammonia, by the way, for those of you who live in this area, did you see this? Yeah, ammonia leak. Not good. Okay. Ammonia is a liquid under pressure. However, it quickly leaks into the air. It evaporates, basically, when there is a containment structure rupture. Therefore, we consider ammonia, this particular chemical, as A, volatile, B, carcinogenic, C, anthropogenic, D, aqueous, E, lipophilic. Volatile, of course. Very good. Aqueous, it's in the water. E, it likes to get into fat tissue, right? Okay. More on that later. Okay, so larger fish have a longer have longer lifespans, and therefore can accumulate more mercury in their fatty tissue over time. So this is an example of A, biomagnification, B, bioaccumulation, C, carcinogenesis, D, aqueous solubility, E, bioconcentration. Okay, so they have longer lifespans, so it's over a period of time. And that would be B, bioaccumulation. That is correct. Okay, so how about this one? Larger fish are at the top of the food chain. They have more mercury stored in their fatty tissue than the smaller fish that they consume. This is an example of A, biomagnification, B, bioaccumulation, C, carcinogenesis, D, aqueous solubility, or E, bioconcentration. A, biomagnification is correct. This is something that happens along the food chain. As the smaller fish get eaten by the larger fish that get eaten by even larger fish, there's more and more accumulation, more and more magnification of the stored mercury. So biomagnification is correct. Very good. Chemicals that are more likely to be stored in fatty tissue and therefore bioconcentrate are known to have A, volatile properties, B, lipophilic tendencies, C, aqueous solubility, D, carcinogenic properties. Well, of course, the key is that they're stored in fatty tissue. So that means that they are lipophilic. Low density chemicals tend to do that most often, right? Right. Okay. It takes approximately 7 years for 5 grams of DDT pesticide to break down into 2.5 grams. Okay. So it's sort of breaking down in the soil. What does this breakdown process over time refer to? Is this called A, half-life, B, LD50, C, bioaccumulation, D, biomagnification, E, bioconcentration? A is correct. This is the chemical's half-life. When the chemical breaks down into half of its mass over a particular amount of time, that amount of time is its half-life. And okay, DDT on average, and it's anywhere from 7 to 15 years or so, actually. So, okay. This part of the atmosphere contains the large ozone layer that absorbs the majority of UV radiation before it hits the Earth. This is A, the stratosphere, B, the troposphere, C, the thermosphere, D, the mesosphere, E, all of the above. It is the stratosphere. Very good. That's A. Okay, moving on. What best describes greenhouse gases? A, dangerous levels of ozone. B, water, carbon dioxide, methane, and other gases that keep the Earth warm. C, ultraviolet radiation trapped by ozone gas. D, anthropogenic gases released into the atmosphere. Or E, all of the above. B is correct. Water, CO2, methane, and other gases that keep the Earth warm. So greenhouse gases are okay as long as you don't have too many of them or too much of them. But unfortunately, there are anthropogenic factors that unfortunately give us too much greenhouse gas, right? So then we start to get a warming in certain areas. And of course, that's called climate change that occurs, right? Okay. If the freshwater glaciers continue to melt, what would be the consequences to the entire planet? A, changes in ocean currents producing changes in climate. B, less fresh water would be available. C, the Earth's rotation would change. D, the planet would warm. E, weather would change. A really is the best answer. Changes in ocean currents producing changes in the climate. Remember, fresh water, when it hits the salty ocean, it changes how the movement in the ocean currents occur and how they progress. And because of that, it will change the whole movement of water, which in the ocean, which is going to change temperature. Well, it's going to change the climate around the planet. So weather is just a temporary, this is just what's happening today. But if we lose the glaciers and they melt into the salt water and make it a little fresher, okay, that's going to cause climate change. All right. The Keystone Pipeline is plotted to travel over the Midwest's largest reserve of water, which consists of porous sand, silt, clay, and gravel. This is called A, watershed. B, troposphere. C, thermosphere. D, river. E, aquifer. Ogallala Aquifer. The answer is E. That is correct. Which, yeah, I think of this and I get very sad. Sorry. Sorry about the sigh. Okay. The study of natural and anthropogenic toxic substances or poisons, by definition, would be A, toxicology, B, toxicokinetics, C, bioassays, D, teratogenesis, E, synergism. Right, it's talking about the study of different kinds of poisons, so that's toxicology. That would be A, yes. Okay, the total amount of a toxicant that can be found within the human envelope at a particular time. This would be A, biological effective dose, B, body burden, C, synergism, D, antagonism, E, absorbed dose. The total amount of a toxicant that can be found within the human envelope at a particular time? That would be B, body burden. That is correct. How about this one? Cancer is caused by A, a lethal change in DNA, B, exposure to a mutagen, C, tumor growth, D, multiple mutations in epigenetics, E, greenhouse gases. Why not? The answer is D. So remember, cancer is going to be the result of multiple mutations as well as the environmental impact of genes. So that's epigenetics. One change in DNA, okay, whether or not it's lethal, I don't know. That wouldn't be it. One exposure to a mutagen, no. Tumors don't have to be cancerous. A wart is a tumor. So yeah, that would not be the right answer. So D is correct. And of course, greenhouse gases. I know you were trying to figure out between D and E, right? All right, so D was the right answer. Good. All right, the amount or quantity of exposure that enters the human envelope is known as A, dose, B, exposure, C, bioaccumulation, D, toxicant, E, toxin. The answer is A. That's the dose. Speaking of dose, here's a toxicant dose response curve. Okay, so looking at this curve, A, B, and C, toxicant A, B, and C have the same measured dose. Which toxicant, however, would be considered more potent? A, B, or C? So look at the response and the dose. Of course, A is correct because A has the steeper slope. Right? Right. A is correct. The boundary below which a non-carcinogenic effect does not occur due to the body's ability to handle or detoxify the toxicant. This is basically a potential for a safe dose. What would we call this? A, the threshold, B, LD50, C, incidence, D, prevalence, E, epidemic. I have to find some other terms. The answer is A, threshold. That is the boundary below which a non-carcinogenic effect does not occur because, yes, the body has an ability to detoxify it. Okay? I can't talk. Sorry. Speaking of dose response curves or doses, refer to the dose response S curve. Where on the curve to the right do you see the threshold for a non-carcinogenic toxicant? Would it be, well, A means here, C, B is D, C is E over here. So is it here, here, or here? Or there's not a threshold for a non-carcinogenic toxicant. So what is your answer? It would be here of all the guesses, right here. So that would be C, which is actually, yeah, that's terribly confusing. So, or excuse me, which the answer is A. I think on a test I might have to fix that graph a little bit. So it'd be right here, okay? I'll fix that. Okay. Tricky question. Using the dose-response relationship model here, what is the threshold for a carcinogenic toxicant? Would it be here, here, or here? Or none of the above? There is not a threshold for a carcinogenic toxicant. The answer is D. There is not a threshold for a carcinogenic toxicant. That is correct. Moving on. What is the order of bioassay toxicity testing used to create dose-response curves? So is it, okay, this is a long one, A, acute toxicity in rodents, then moving on to subchronic rodent bioassays, moving on to chronic rodent bioassays, and then finally to bacterial tests. Or B, start with bacteria, move to subchronic rodent bioassays, from there to chronic rodent bioassays, from there to humans. C, start with acute toxicity in rodents, move to subchronic rodent bioassays, moving to chronic rodent bioassays, and finishing with bacteria. D, start with chronic rodent bioassays, go to subchronic rodent bioassays, and then move finally to acute toxicity in rodents. Or E, start with bacteria, move to acute toxicity in rodents, then to subchronic rodent bioassays, and then finally to chronic rodent bioassays. You got it. Start small with the bacteria, and then finally to chronic rodent bioassays. So E is the correct answer. Very good. So why are rodent bioassays useful in studying carcinogens, you ask? Well, could it be A, cancer onset is directly related to age? B, rodents have a short lifespan and get old fast? C, like humans, rodents are animals. D, we cannot ethically test toxicant dose responses on humans. Or E, all of the above? That is correct. E, all of the above. Very good. All right. The absorption, distribution, metabolism, storage, and excretion of toxicants describes toxicokinetics, toxicogenetics, toxicodynamics, toxicity, or toxic dose. I can talk. I'll leave you so you can figure that out. Okay? Got your answer? That is correct. You have, well, at least I hope. Toxicokinetics is correct. Good. Consider the dose response toxicity testing and the response dose curve. Where would you suspect to see the NOEL or highest non-zero dose at which no effect was observed? Would it be, okay, I've got this one figured out here. A, which is A, B, which is B, C, which is C, D, which is D. What do you think? That is correct. So you're going with A. A would be your NOEL, or NOEL. You got that right. Okay. Consider the dose response toxicity testing again. If A is the NOEL and C is the LOEL, at which dose do you get toxicity? Again, A, B, C, and D. I've got that worked out. So what do you think? Right, it's got to be B. It's always between the non-zero dose at which no effect was observed and lowest dose at which an effect was observed. So observed. So it's always got to be between NOEL and LOEL. So very good. Between A and C. And that would be B. B is your answer. Lead is a common neurotoxicant that is particularly harmful to children. Children typically ingest or inhale lead-containing dust in the homes and their environment, accumulated from paint, plumbing, and leaded fuel emissions. There is no safe level of lead exposure. Lead exposure has been linked to cognitive, physical, and behavioral disabilities. In February of 2012, the Centers for Disease Control and Prevention adopted a blood lead reference value of 5 micrograms per deciliter, reducing by half the level at which intervention is recommended. An estimated 450,000 U.S. children have blood lead levels above that reference value. Yikes. What is considered a source in this description? A, lead. B, the nervous system. C, children. D, dust. Right, D, dust. Okay, especially with the little kids. Remember the pig pen analogy. So yes, dust would be considered the source. Okay, same scenario. Okay, where is the biomarker found in this description? Is it A, the nervous system, B, dust, C, blood, D, paint, E, all of the above? Well, it's the blood, right? So it's C, because what they're doing is they're doing the blood lead test, right? The nervous system, well, yeah, no one wants to have that biopsy done, okay? So there you go. So it would be in the blood. That's the biomarker. Good. So same scenario. Now, if you really wanted to use a biomonitoring system and you wanted to be thorough to track exposure and relate exposure to dose, what would you use? A microenvironment biomonitoring system. B, a personal environment biomonitoring system. C, both a microenvironment and personal environment biomonitoring system. Or D, none of the above. Right, C. Use the monitoring system for both the microenvironment and the personal environment because, well, it's true, they're looking at all of the sources in the home, but they're also looking at other sources, including leaded fuel emissions, and maybe you wanted to test schools. So, yeah, just to be thorough, why not? All right. The amount of dose that reaches the target sites within the body. What would that be called? A, the effective dose. B, the absorbed dose. C, the exposed dose. D, the envelope dose. Or E, toxicodynamics. So that would be A, right? The effective dose. That would be A, effective dose. The absorbed dose and effective dose would be part of the blank model of exposure. So would this be A, the toxicokinetics model, or B, the toxicodynamics model, or C, possible health outcome model, D, route of exposure model, or E, emissions model? That would be toxicokinetics. Okay? That would be A, toxicokinetics. All right. The toxicant effects in the body. What would that be? Signs and symptoms. Is that toxicokinetics? B, toxicodynamics? C, possible health outcome? D, routes of exposure? Or E, emissions? Emissions, sorry about that. That would be B, toxicodynamics. Very good. Okay. If a chemical does not produce accessible, measurable biomarkers, what can you investigate in your surveillance work to quantify exposure? Okay, so toxicokinetics, A, B, biological monitoring, C, health effects, D, absorbed dose by biomonitoring, or E, all of the above. Well, you could go with D, absorbed dose by biomonitoring. The contributions of epidemiology to environmental health include which of the following? A, concern with populations. B, use of observational data. C, methodology for study designs. D, descriptive and analytic studies. Or E, all of the above. You're right. Epidemiology is going to involve all of the above. So, and these are all of their contributions. So E is correct. Good. Taking acetaminophen can be a liver toxicant. Alcohol can be a liver toxicant. Taken together, the effect is even more damaging than if the effects were measured separately. This is an example of A, antagonism, B, synergism, C, teratogenic, D, surveillance, E, bioassays. B is correct. Synergism. Very good. Morbidity Mortality Weekly Report, also lovingly known as MMWR, is a weekly epidemiological published report produced by the CDC. Morbidity and mortality are defined directly and specifically as A, limitations on activity and death, B, new cases of disease and prevalence of disease, C, treatment and prevention of disease, D, disease and death, E, descriptive epidemiology. So what's morbidity and mortality literally? D, disease and death. Absolutely. Okay. The MMWR, actually, May 26, 2017, reports that tobacco smoking is high among youths in many countries. Global Youth Tobacco Survey data from 61 countries from 2012 to 2015 revealed the median current tobacco smoking rate among students aged 13 to 15 years was 10.7%. Yikes. Okay, this is an example of A, incidence, B, prevalence, C, mortality, D, morbidity, E, all of the above. So yes, B is correct because we're looking at prevalence. We're not looking at disease and death, nor are we looking at new cases. This is just looking at in general, okay, so how prevalent is smoking? Okay, so that's prevalence. The MMWR, okay, September 2006 article said that a blank analysis was conducted of reported various enterovirus isolations during a 36-year period and for 3 10-year periods, okay, and 1 6-year period, okay, by month of specimen collection, specimen type, patient age, sex, and outcome, and assess trends in the number of reporting states and the impact of changing laboratory practices. Okay, so just looking at this, would you consider this as an example of A, descriptive epidemiology, B, analytical epidemiology, C, experimental epidemiology, D, all of the above? Right, so this has to be descriptive epidemiology because that's when you're just looking at patterns. You don't know about the disease, you're just looking at comparing disease rates across different places and times, and that's what we're doing here. And you don't interfere, so there's no analytical, experimental epidemiology here. You're just observing and you're describing just over time. That's all you're doing. Okay. According to AIDS.gov, there were approximately 36 million people worldwide living with HIV/AIDS at the end of 2015. There were approximately 7,200 million people on this planet in 2015. An estimated 2.1 million individuals worldwide became newly infected with HIV in 2015. What would be the crude incidence rate in 2015? Now, you don't need to pull out the calculator, just tell me what numbers. What would be the numerator and what would be the denominator here? Okay, and since it says crude incidence rate, what do you think? 36 million plus 2.1 million, 36 million per 2.1 million, 2.1 million per 7,200 million, 36 million per 7,200 million, or 2.1 million per 7,221 million. I don't know. Okay, so what do you think? Well, okay, it's incidence. So we're looking at New cases, right? So that's going to be the numerator. So 2.1 million over total, over the total population. So the answer is C, 2.1 million over 7,200 million. And that would be how you would calculate the crude incidence rate, okay? Again, it's not the numbers, you just have to recognize, okay, numerator over denominator. So there you go. A blank study among healthy passengers was conducted on board a ship. Questionnaires about healthcare seeking behaviors, hygiene practices, and possible norovirus exposures were placed in every cabin. Norovirus is a fecal kind of virus that gives people a lot of GI distress, also known as the Hershey squirt. So there you go. After the cruise, stool samples from healthy and several ill passengers were taken. Samples were tested for norovirus. It was determined that passengers with good hand hygiene practices were less likely to develop diarrheal disease. What type of study is this? And yeah, this started out to be a real case study, and then I played with it a little bit. So what do you think? Well, okay, so if you said cohort observational, you would be right. So it's cohort. You're looking at exposed, non-exposed, and of course it's observational. Okay, so you're starting off with all these healthy passengers. Starting off with the healthy passengers, and okay, you're just letting them go. Let's see who gets who gets sick, who stays healthy. You've got this questionnaire to kind of track them over some time, and there you go. So again, observational, exposed versus non-exposed. Okay, all right. The relationship between use of conjugated estrogens and the risk of endometrial cancer was examined among 188 white women aged 40 to 80 years with newly diagnosed endometrial cancer, and 428 controls of similar age hospitalized for non-malignant conditions requiring surgery at the Boston Hospital for Women Parkway Division, Massachusetts, between January 1970 and June 1975. So what kind of study is this? Is this cohort observational, case control observational, observational randomized, or experimental randomized? Right, hopefully something jumped out at you. So we're looking at new diagnosed cases of endometrial cancer. So that's the case. And they even give you the controls, 428 controls. So, and they're not interfering with anything, so it has to be observational. Okay, so it's got to be B, case control observational. Very good. Andrew Wakefield's findings linking the measles, mumps, rubella vaccines to autism was flawed on many levels. What was one of the major problems? Just one. A, synergism effect. B, confounding effect. C, selection bias. D, findings were due to chance. E, all of the above. Well, of course, it was selection bias. He only had, well, there was a lot of things, but his subjects were referred to him by the law firms. So that's one of the problems, okay? So those 12 random children, yeah, whatever, okay. Um, when trying to determine if an epidemiological study association is causal, scientists use A, observational studies, B, bias studies, C, confounding studies, D, Bradford Hill's criteria, E, dose studies. And indeed, if we're looking at epidemiological study association, the one thing that scientists really look at is Bradford Hill's criteria. Okay, that would have really broken down Wakefield's study had anybody use that criteria. So there you go. All right, ticks are plentiful right now. Oh my goodness, I just had one on my back the other day. Certain ticks are known to carry the bacterium that causes Lyme disease. Ticks are blank of Lyme disease. What do we call that? Are they pathogens, vectors, virulence, animal bioassay subjects, or all of the above? Hopefully you said B. They are vectors. That is true. Okay, here's another study, another type of case study. A number of passengers on a cruise ship from Puerto Rico to Panama Canal have recently developed a gastrointestinal illness compatible with norovirus, formerly known Norwalk virus. I know nobody wants to go on a cruise after this class. The incidence rate is higher than anticipated. So then it would have to be considered A, epidemic, B, pandemic, C, endemic, D, risk, or E, experiment. Okay, when the incidence rate is higher than anticipated, then, and it's not going to be a pandemic, it has to be an epidemic. Okay, so there you go. A study in which children are randomly assigned to receive either a newly formulated vaccine or the currently available vaccine and are followed to monitor for side effects and effectiveness of each vaccine would be an example of which type of study. A, experimental, B, observational, C, cohort, D, case control. Of course, this has to be experimental, A, right? So you are manipulating, you have your group, and actually it's a random experiment. So the subjects are randomized into 2 intervention groups and then monitored, right? So, got to have, it's going to be manipulated. It's going to be experimental. All right. Teratogens are known to affect the development of developing organisms. A teratogen known as thalidomide was given to pregnant women to reduce nausea. However, this caused birth defects in the developing fetus. This chemical then would have to be considered or would be considered to have A, developmental toxicity, B, carcinogenic toxicity, C, reduced toxicity, D, reproductive toxicity, or E, limiting toxicity. Of course, it's A, developmental toxicity. Interestingly enough, they give thalidomide as a cancer treatment. My mother took it when she had bone cancer, and it would have worked had all the other problems not have pretty much overwhelmed her. But there you go, thalidomide. This describes how communities get involved in public health research that contributes to decision making and hopefully practical solutions to public health problems. Would this be A, community, political, and social activism, B, community-based participatory research, C, Danish-style consensus conference, D, U.S. Toxic Substance Control Act, E, European Union's REACH program? What do you think? Well, of course, B, community-based participatory research. Very good. The hallmark feature of an analytic epidemiological study would be, okay, what's the best answer? A, use of an appropriate comparison group. B, laboratory confirmation of the diagnosis. C, publication in a peer-reviewed journal. D, surveillance using biomonitoring systems. So in an analytic epidemiological study, what do you really have to have, you guys? A is correct. Use of an appropriate comparison group. Very good. We have known for thousands of years that nearly all sick people have eaten carrots. After calculating relative risk, scientists have determined that no risk is apparent. What might that relative risk number be? Okay, so there's no risk. This is relative risk, but what would that number be? So what looks good? 58.0006, 1, 100, or nada, nothing. So if there's not a risk, that number would have to be 1. 1 is correct. It has to be 1. That means that, okay, there is no relative risk. Okay, ready for another one? All right. Which of these relative risk numbers represents the kind of protection provided by vaccines? Would it be A, 58, B, 0.0006, C, 1, D, 100, or E, goose eggs? So what would that be? Right, anything that's protective. When it comes to relative risk numbers, it would be anything below a 1. So there's only one answer to that, and that has to be B, 0.0006. So, so I just made that number up. I don't know if that is, if that is a true number, but there you go. Okay. Now, I don't smoke cigarettes, so for me, cigarette toxicants would be considered A or AN. A, hazard, B, risk, C, hazard and risk, D, incidence, E, prevalence. Of course, it's a hazard, not a risk, but it will always be a hazard. Okay. For non-carcinogenic effects, risk, okay, we're looking at risk, what must be evaluated and compared? So we're looking at the risk for non-carcinogenic effects. Okay, what do you have to look at and compare, if you remember that? Is it exposure, A, B, toxicity, C, treatment, D, toxicity and exposure, E, toxicity and treatment? Of course, well, if you remember my little circles there, it has to be toxicity and exposure. Risk is right where they overlap, right? So the answer is D. You can be exposed to 0.005 milligrams of inorganic arsenic per kilogram of body weight per day without adverse effects, basically in people. That's 0.005 milligrams arsenic per kilogram per day. What is this describing? And by the way, this is the truth. Or at least that's, I should say, this is what the CDC found. So what would we be talking about here? A, fate and transport of a toxicant. B, pharmacokinetics. C, reference dose. D, relative risk. E, incidence. Well, of course, it's the RFD. It's the reference dose, isn't it? Right? So that's saying that you can be exposed to that particular level and below that level, and supposedly you don't have adverse effects. So I vote for no arsenic at all, thank you. But guess what? Sometimes it's there. All right, how is a reference dose calculated for non-carcinogenic toxicants? Do we use rodents? Do we use Noel? Do we use Lowell? Is the dose calculated from animal bioassays, but the dose is lowered for humans and animal exposures? Or maybe E, all of the above? Yes, of course. It is all of the above. You got it. So that's what you can do for non-carcinogenic toxicants. You use the rodents, you can look at Noel, you can look at Lowell, but whatever number you have from the animal bioassay, of course, you probably want to lower it a bit for human exposure. What is the RFD, okay, for carcinogenic toxicants? So the reference dose for carcinogenic toxicants. A, that depends on the threshold. B, that depends on the Noel. C, that depends on the Lowell. D, that depends on Noel and Lowell. E, there is not a reference dose for carcinogenic toxicants. E is correct. There is not a reference dose for carcinogenic toxicants. So yeah, none of the above. So can't do that. So then, how are carcinogenic effects calculated? Is it A, by the reference dose, B, by the probability of developing cancer, over a lifetime. C, by the immediate exposure and dose ratio. D, by the number of milligrams of toxicant in the exposure. E, by the risk association. Okay, so this is not as hard as it looks. It's just simply B. Remember, the carcinogenic effect is calculated by the probability of developing cancer over a lifetime. Don't make it too hard. Okay, and remember, it doesn't have units, so the milligrams and stuff, that just isn't gonna, that doesn't fly. Hazard identification, exposure assessment, dose response assessment, and risk characterizations. Yeah, and risk characterization describes A, the risk assessment process, B, relative risk, C, prevalence, D, transport and fate, E, toxicokinetics. What do you think? So what is that really describing? Right, so that's A, the risk assessment process. The four, right, the four steps: hazard identification, exposure assessment, dose response assessment, and risk characterization. That is by definition the four steps of the risk assessment process. Okay. The lowest risk that can be reasonably achieved for individual chemicals and sites. So what would that be? A, negligible risk. B, alternative risk. C, threshold risk. D, acceptable risk. E, precautionary risk. Of course, that is acceptable risk. That is D. All right. Risk communication about vaccines and public safety still remains difficult, even though all evidence linking autism and the measles, mumps, rubella vaccine have been disproved. This problem is due in part to A, hazard identification, B, hazard plus outrage, C, lack of evidence, D, precautionary principle, E, health impact assessment. Okay, so yeah, it's B, it's hazard plus outrage. So that's sort of getting in the way of evidence, unfortunately. Okay, people judge risk differently. Scientists definitely. They're all about calculating risk. Okay, this approach to make environmental health policy states that early warnings of serious harm from a substance or activity call for actions before there is clear proof of harm. So we call this a reference dose, B, a threshold principle, C, the precautionary principle, D, Bradford Hill's criteria, or E, community-based participatory research. And of course, that's C, precautionary principle. So we're being cautious, you know, we want to be able to perhaps put out the alarm, stop things before they get out in the community. So there you are, without really a lot of proof before we have to provide a whole bunch of burden of proof. Okay. Speaking of which, according to the U.S. Toxic Substance Control Act, who specifically is responsible to determine whether a chemical is likely to meet safety standards before it enters the market? So clearly this is in the U.S. Is it A, all manufacturers and distributors of the substance? B, all governing bodies? C, the Environmental Protection Agency, also known as EPA? D, the Food and Drug Administration, also known as the FDA? The E, National Institutes of Health, or known as NIH. Which one would that be? Right, FDA, Food and Drug Administration. Right, it's all up to them. Oh, joy. Okay. Whoop, sorry. Okay. This precautionary approach to environmental health policy involves a panel of citizens who question authorities and then deliver a report after a 3-day process. So is this A, precautionary principle, B, Bradford Hill's criteria, C, community-based participatory research, D, Danish-style consensus conference, or E, health impact assessment? Well, of course, it's D, the Danish Style Consensus Conference is correct. Okay. The amount of a toxicant that kills half of the test subjects, such as mice, would be known as the A, body burden, B, threshold, C, effective dose, D, threshold dose, or E, lethal dose 50, or LD50. Well, by definition, okay, anything that kills 50%, that's going to be your LD50. So, good. Well, that's all I have, and my voice is leaving me. So, if you did well on the quiz, you should do well on the test. If you have any questions, by all means, please, email me, let me know. And again, good luck, everybody.